I built an app that uses AI to transcribe podcasts and allow you to ask questions about what happens in those podcast episodes of an LLM, and the LLM will respond based on what it knows from the transcript. I wanted to figure out two things. One, how much does this cost me for the typical user to download an average podcast and transcribe it, and then be able to ask questions about it. The second thing I wanted to learn is how much energy this uses. And I wanted that to include the energy from my computer, the energy from the server, and if possible, the energy from running these queries on the API itself. So I'm using OpenAI and the Whisper API to do this. So that would be wherever they run their servers, how much energy is being consumed there as well. So the first thing I did is I'm closing as much as I can on my computer in terms of applications. I've got a lot of kind of extensions running up here and things like that. I haven't bothered to turn those off. So they will maybe have some minimal power draw that would affect things. There's obviously going to be system processes that are running, and you can see those via the activity monitor. And if we wanted to, we could shut down as much as possible of those things. So you can see kind of the percentage of the CPU that they're using up, but you can also see that the CPU usage on my computer is very low right now, 98% idle. So shouldn't affect things too much. The other thing that has to run is this screen capture software in order for you to be able to see what I'm doing here in this video. So the next thing I want to do is in Firefox, I have a really great power profiler. So if I go to this performance tab, you'll notice I've got the power setting active here. And I'm going to make a recording of using my app. So it's recording. And now I'm just going to use the app as normal. I'm going to search for a podcast. Here it is. And I'm going to pick an episode. This one is about Charter, Disney, the broadband market, etc. It's going to go find the MP3 URL for that podcast, and it's going to download it. Now, in order to transcribe it, Whisper requires files of no more than, I believe, 20 megabytes. So it's splitting the file into chunks. You can see we've got 10 chunks here, and this is going to take a while. So I will fast forward through this. And you can see it's made those chunks, and it is transcribing each individual file's audio to create those embeddings. And what those embeddings will do is we can provide those to our large language model, which I'm also using OpenAI's GPT 3.5, to be able to ask questions about what happens in this podcast episode. So again, I'm going to fast forward. Now it's transcribed my files, and it's setting up the LLM, giving it those vector embeddings. And now you can see I get this text box where I can ask questions about my podcast. So let's ask a question. So I'll do one more question, and this is a different mode of the podcast that will take you to a certain place in the audio and then play the audio from that podcast around the relevant context. I didn't find that.
not we're going to forfeit $1 billion in revenue or $2 billion in revenue that we get from Charter Spectrum because we don't want to give away our ad-supported streaming service, which we're already trying to grow anyways. Like, it just was a weird battle to fight. And given the stakes, they had more to lose.
So this is probably some average user activity for the website. And so I'm going to go ahead and capture this recording and take a look at my network traffic. This will take a bit of time, and then Firefox will open up the profiler, and we can see what our computer was doing while we were running this website. Now, I will admit that I don't know a ton about the profiler or network performance or code efficiency, things of that nature, which is even more reason for me to want to understand this stuff, because then I know if I'm writing some very efficient code that is going to be costing me a lot of money. But I will run through a few of the things that I've found are worth looking at here. First and foremost, just as a general overview, we have our network traffic, and then because we ran this in this power mode, the profiler shows us the power usage of our CPU, of our RAM, of our GPU, and I haven't configured this website to utilize that at all. I'm not doing anything graphics intensive or whatever. And all of the machine learning is happening on the OpenAI servers, not mine. And then if we scroll down, we can see the rendering. This is when the website first loads, I'm assuming. And how would I know that? Well, they have this awesome set of screenshots here that stays in sync with anything I'm doing as I'm testing my app. So I can correlate the screenshots with the web activity and energy usage. So here where the CPU spikes, I could go down and look, and this is when I switched modes. So there's probably some more graphics and page loading happening, so the CPU gets hit a bit harder. Now, if we go back up to the power and highlight one of these little inflection points here, we can see what the power usage was at that point, 2.43 watts. If I look at the energy used in the visible range, which is the entire recording, I've used 164 milliwatt hours, or 72 milligrams of CO2 equivalent in energy. Okay, so is that a lot, a little? I'm not exactly sure. I vaguely remember that EPA has a, here it is, greenhouse gas equivalencies calculator. So we were dealing in milliwatt hours. So that was, again, 164 milliwatt hours. So in watt hours, that is 0.164. In kilowatt hours, that is this number, whatever that is. Kilowatt hours used. So the equivalencies are all very small, with the exception, probably the closest we'll come here is 0.014 smartphones charge. So you could charge your cell phone 1/100th of the way, roughly, on the amount of power that was consumed in that session. So this is not a lot of power being used by my computer. Obviously, we want to know what the server was doing, and we'd like to know what OpenAI's servers were doing, because they were doing probably most of the work. If we look at this network tab, that might be another thing that's worth showing in the profiler, because we can see actually all of the network traffic that was happening from the client. And so it's communicating with our app, and we can see the API endpoints that it's hitting. So it searches for a podcast, searches for episodes, it transcribes them, and then it's going to get the status of the transcription. And you can see we've got repeated calls for that because I'm polling to see, are you ready? Are you ready? It's taking a long time. And then in these perform user query steps, we're actually asking the API to answer our questions, and it's responding back. So you can see kind of some slightly, these longer response times, slightly longer response times, 2,000 milliseconds, so a couple of seconds to go and fetch OpenAI and ask questions in real time. The other one that's very long is the podcast download here. And then we've got some sneaky thing from Amazon here. I don't know what that's about. Hopefully it's about something related to AWS and not some shopping bot thing hiding on my computer. So the next thing we want to do is figure out what is happening on the server. And you probably saw that this is a Heroku app. So I'm going to go to my Heroku dashboard, and I've actually not used this. I was originally running an Eco Dyno, which is something that Heroku provides that actually shuts down the server when it's periods of low traffic. But in their standard dyno, you get these metrics. So we'll take a look at those. So we were active from about 11:30 to 11:39. So we want to just isolate that range here. And this is UTC. So it's looking like we have to upgrade if we want specific times, but let's at least get the time zone right here. So I'm hoping this tells us something useful about energy usage. We have memory usage, which during this time was actually above our quota. We have a quota on this dyno of 512 megabytes, and we used at max 954. So it was spiking when we were doing some of that file processing. I was using FFmpeg to split apart those MP3 files, and I think that's what that is. So that's at 186.4%. So obviously there was some energy consumed there if we're using memory, but we don't necessarily have that output in terms of milliwatt hours or kilowatt hours the way that the Firefox profiler does. Response time, again, kind of spiked here. Let's see how long this is. 2 seconds to provide a response. Throughput, this is number of requests per second, and that's not going to help us that much. Dyno load, this could potentially be something useful. Let's see what that is. A runnable task on the CPU. Average for a 10-minute sampling interval. So our average was 0.04 over a minute. So we're not putting a large load on the server. There's not a lot of requests coming in. Again, I don't think this helps us. So as far as our metrics, maybe that tells us more about the fact that energy usage hasn't really been prioritized as a measurable metric for server admins or for cloud providers, etc. So because we have the energy data here in this profiler, let's just figure out, maybe it's because it's just so negligible, it's not even worth measuring. Let's figure out the total of what we used. We've got 164 in RAM, milliwatt hours, 1.13 watt hours, plus 0.164, and then 850 milliwatt hours there, so plus 0.85. Basically nothing here. 34 microwatts on the GPU. So 2.14 watt hours. And I came across a website that tells you what your energy costs you, which is, I don't know, a good thing to know, I think. So 2.14 divided by 1,000, that's 0.00214. That's what we used in kilowatt hours. And this was called the Electric Power Monthly, U.S. Energy Information Administration. Here's what your energy costs you in cents per kilowatt hour. So I'm in Oregon. My electricity costs me 13 cents per kilowatt hour. You can see this is below average. That's because California, they charge more for the energy used. It'd be interesting to see who charges the most. Hawaii, not surprisingly. So if it's 13 cents per kilowatt hour and we use 0.00214, I think, we consumed 0.03 cents worth of energy. But what did it cost the planet? Man, energy's cheap. Maybe it shouldn't be. Maybe it shouldn't be so cheap. Heroku, because they just charge us for the number of dynos used, unless we have to scale up our number of dynos, we're not going to get a good sense of cost and power usage here. So let's go look at OpenAI. Here's OpenAI usage, and here is today. Now, I did run an initial session before I recorded this, so that will probably be reflected here. But you can see we've got both language model usage and audio API usage. We don't have any fine-tune training. We're not fine-tuning a model. We're, as I mentioned, using embeddings. So that will actually be a much more efficient use of resources. You can see for the entire month, I've spent about $12, and this day has only been about 70 cents of that. So the first thing that we did was we used the Whisper API to transcribe the podcast. And again, we started around 6:30, so it's going to be this chunk here. So 4 requests, 2 requests. Those are those 10 chunks of audio files that each get transcribed. 1,200 seconds of audio, so they're broken up into 300-second chunks. So if we had 20 requests at 70 cents, then half of those were in our recorded session to transcribe the podcast. So that's actually 35 cents is what it costs for a user to be able to transcribe their favorite podcast. That tells me a lot already, because it means that unless I'm caching or storing these transcriptions, I'm going to continually get hit with that cost, which is not necessarily cheap, every time somebody transcribes an hour-long podcast. Obviously, if the podcast is shorter, the price is cheaper. So as a developer, I'm thinking the first thing I need to do is come up with a good solution for that before I worry about any other performance-related improvements, if I want to get my costs down, get my energy usage down, etc. So this is already helpful. Let's look at language. Again, we'll dive into this segment. So this is when we started asking questions to the LLM. So it's broken down into prompt and completion. So we had to build a context of understanding for the large language model, and that was 28,315 tokens of context. And then probably add on an additional 2,932 here. That might include the podcast episode, and it just got broken up because of the time interval. But it also, we're adding to that context whenever we ask a question. We're saying, given what you know, and given what I'm telling you now, provide me an answer. And so that completion, the 252 tokens, is the amount of text that OpenAI and ChatGPT gave back to us. So we're being charged for that as well. So all in all, we've got 12 28,315 plus 3,184. That's about 31,500 tokens of text. And that translated into about 35 cents. So you can see what we're being charged there. So the next thing I might want to do, if I wanted to reduce my costs, reduce the amount of energy I was using, make this app faster and better, is be able to identify what portion of the audio the user is asking questions about and only provide the model that context. So because we're already splitting these audio files up, we could be isolating, based on the nature of their question, where in the audio they're asking about and only providing that to the context window. I'm not doing that. I'm just feeding the whole thing. That's very inefficient, but it's also a much harder problem to solve. So if this app were to scale, I would start digging into that. But as I mentioned before, I'm going to first look at how to store these transcriptions so we're not transcribing that file every time. The last thing I want to do is look at what OpenAI charges for this stuff and make sure that squares with what we saw in our billing. They've got this table here. We were using GPT 3.5 Turbo, I believe. This is a 4K context. And it looks like you're being charged 0.002 cents per 1,000 tokens of output. Slightly less for input, which is our context again. And then for Whisper, they charge 0.006 cents per minute. So roughly 3 times as much and per minute versus per 1,000 tokens. So if we had, say, I think it was about 70 minutes of audio times 0.006, it's about 42 cents. We said we were only charged about 35, so I don't know. Maybe it's Discount Tuesday, or maybe our podcast was a little shorter than I thought it was. But that means then that, what did we say, our input was, say, 31,250 tokens times 0.0015 divided by 1,000 tokens for that price. So nothing, but 0.05 cents for that context. So it's mostly all, again, a charge for the audio. That's the thing that's expensive. That's the thing that's probably consuming the most energy, takes the most compute. Because this model is already chained, the inference to be able to answer our question on some small amount of embeddings isn't that intensive. So I'm convinced that's my focus area for this app. One last thing I will point out is make sure to set your usage limit to a price that you're comfortable with. I don't know if they have a default. They might not set this at all, but they give you the ability to set your limits. And if you're not careful, you can end up spending a lot of money on these APIs when you're playing around with them. I have definitely found that out the hard way with other services. So I've set a $20 limit here with a soft limit of $10 where they warned me that I've reached this threshold. So one, it's a good way to know if people are using your service, but two, it keeps you out of financial woes. Okay, last thing on energy, I promise, because I know Probably most folks don't care about it as much as I do, but I really do want to know what toll these things are taken from a first-hand perspective of something I use versus just these abstract figures. I couldn't get that, obviously, from OpenAI is not going to tell me. And it's going to be highly variable, hard to measure, but I did find a Reddit thread where they posted the different energy consumption of different services, and we do have a ChatGPT figure, which is 0.01 kilowatt hours for the average query. I would say while we have an average query, we have a much larger context window, so that's going to factor in, and we're probably going to be maybe a little bit higher than that figure if it's correct. Now, the interesting thing is maybe not that energy usage, but how does it compare to a Google search query? And from this chart, it looks like it takes about 15 times more than a Google search query. So think about that the next time you are asking ChatGPT a question that you could do a Google search for. It is more energy intensive. I think the figures probably are highly variable, highly depend on what you're searching for. They're not taking into account probably then the rabbit hole that you have to go down with that Google search query to find what you're looking for. But those are the figures on the executing the query itself. So let's just recap what we learned here. Transcribing audio is a computationally expensive process, both on the client, the server, and the API side of things, which is why it costs more. Optimizing that process is a good idea if you're working with audio. Minimizing the context window for what you're asking an LLM is also very important. Making sure you're providing, just the most relevant data to an AI in order to answer your questions if you're using, this sort of embedding model. We learned that the Firefox profiler has a lot of tools that you can use to understand what's happening when someone is interacting with your AI-driven app. We can see power usage, we can see screenshots that we can correlate with network activity, etc. You can see how long responses take, and we can subsequently correlate that power usage to a cost and an environmental impact. If we wanted to understand everything, we would need to understand what's happening on our server. Heroku doesn't give us that option. I could run this locally and probably find a way to get the energy usage while using my local machine, maybe from the activity monitor, maybe from just running the Firefox profiler while I navigate locally. But we would need some kind of measure there. Same thing with OpenAI. We have some rough figures that people have posted in forums like Reddit on what these queries cost. We obviously have the price that OpenAI charges us. We learned a little bit about what a Google search query consumes in terms of energy versus what OpenAI and ChatGPT consumes. We learned where to find out what your energy costs you on average. We learned how to equate energy usage to real-world metrics like gallons of gas consumed or phone charges. And just keep in mind that all of this stuff is highly variable. There's a lot of things that go into it. Grid intensity factors in, right? Like peak power usage versus non-peak, where you are in the world, where you're drawing your power from, how far away that source is, whether it runs on renewable energy versus coal, etc. All of these things factor in. So you're not going to get accurate figures per se, but you will get a much better understanding of what it costs to run all this compute and whether it's worth it for the app that you're building. Hopefully this has been helpful. If you have any questions or clarifications or things that might be useful in this regard, please feel free to leave comments. I will post links to some of the resources shared in this video in hopes that they might be helpful for you. Thanks for watching.